Okay guys, in this video I'm going to work through page 390, maybe on to 391, I'm not sure. It's chapter 7.6, focused on solving logarithms and exponentials. Now the key to solving logarithms and exponentials is realizing that they're the inverse of one another. Okay? So they're the inverse of one another, and what we're going to be doing is actually using, so if it's given to me in logarithmic form, then I'm going to use an exponent to cancel out, a portion of that log. If it's given to me in exponential form, I'm going to use a logarithm to cancel out a portion of that exponential. So, for example, one thing you need to remember is if I have like log base 7 of x equals 4 or something like that, and I want to get this x by itself, my objective in solving is getting x by itself, then I'm going to go ahead and raise, if this is equal to that, if log base 7 of x is equal to 4, and they're the same thing, then we should be able to say that 7 to the power of log base 7 of x should be equal to 7 to the 4th power. Because remember, log base 7 of x and 4 are the same. So 7 to some number should be the same as 7 to that same number. Okay, that's what we're doing, essentially. But if we realize that exponentials and logarithms are opposite of each other, then 7 to the log base 7 cancels. So I end up with x equals 7 to the 4th power. Okay? So that's an example of if I was given a log, how I solved that by using exponentials. Now I'm going to show you if I was given exponentials, how I would solve that by using logs, and then we'll get started solving these. I'll do the odds. So if I was given an exponential, so like 3 to what power is 10.712? Something as weird as that. You can answer this question using logs. So it's an exponential in the moment, but I'm going to use logarithms to cancel out my exponential so I can isolate that x. So once I have my base by itself like this, I can do log base 3 of 3. Now what I do to one side, I have to do to the other. So I also need log base 3 of 10.712. Log base 3 of 10.712. Now what happens when I do this is log base 3 of 3 cancel. So I have x equals, and then what's left is log base 3 of 10.712. And that's, there's an answer for that. So remember, you can just do control log, so log base 3 of 10.712. So to answer the original question, 2.15, so 3 to what power is 10.712? The answer is 2.15851. So 3 to the 2.15851 is 10.712. Okay? A third and more complicated version of solving is when you look at like number 11, and you end up having like 49 to the 5x plus 2 equals 1/7 to the 11 minus x. There's two complicated things on here. First of all, notice that there's an x on each side of the equal sign. Okay, so if we're going to deal with that properly, we need to find a common base. Okay, now some of these are nice enough to give you a common base. Like, for example, number 5, notice the base is 7 on both. You have an x on both sides, but the base is 7, so that's going to make it really easy. And when we solve number 7, you'll see that. But for something like number 11, where the bases are different, you have to turn those into a common base before you actually get rid of the exponential base using logs. So you'll see that when I get to number 11 to number 7 a little bit. Starting off with number 5, I'll show you why it's so simple. So if I have 7 to this power equals 7 to that power, and I have x on both sides, I'm going to cancel out that base of 7 by doing log base 7. So log base 7 of 7 to the 3x plus 5 equals, what I do to one side, I have to do the other. So log base 7 of this side, log base 7 of this side. So 7 to the 1 minus x, like that. Now log base 7 of 7 cancels, log base 7 of 7 cancels, so I get 3x plus 5 equals 1 minus x. Solving this, I get 4x equals negative 4, or x equals negative 1. And I can check that by plugging it back in, but I'm going to go ahead and move on. So that's number 5. Number 7, 5 to the x minus 3 equals 25 to the x minus 5. Now, I have x's on both sides. Here's a complicated one. X's on both sides, but my bases are different. If I wanted to get rid of my bases, I need the same base. So 25, though, in terms of 5, is simply just 5 squared. So here's 5 squared. So I'm going to have to multiply that squared into the x minus 5. But outside of that, now I've got the same base. I have base 5 on both. So if I have that, I'm going to go ahead and do log base 5 of each side. And when I do that, log base 5 of both sides, the 5's cancel with the log base 5. And I have x minus 3 equals 2 times x minus 5. So I'm going to distribute this. So I have 2x minus 10 equals x minus 3 and finish solving this. So I'm going to add the 10, subtract the x equals 7. Like that. All right, on to the next one. You might think this is really complicated right now. Just watch a few. They're all the same sort of idea. So here's one where I only have one x. So if I'm given one x instead of an x on both sides, so like number 49 or number 11 again has 5x plus 2 on this side as an exponent and 11 minus x on that side. So that's a whole different ball game. But as far as number 9, I've got one x, 3 to the x equals 7, and I want to isolate that x. I want to pull it out of the exponent area. So again, my objective is get rid of that base. So to get rid of the base, I need to get rid of that. Give me some space. I need to do log base 3 so those can cancel. Now, I have to do it to the other side as well. But I end up with x equals log base 3 of 7. And that is an actual answer. I just need to type it into the calculator. So log base 3 of 7. So it's 1.77124. So x is approximately 1.77, I don't remember what the rest of that decimal was. But that's how you do that one, if you have one x. So here's number 40, or I keep saying 49 because I see the 49. Here's number 11. This is a very difficult one, okay, with an x on both sides. So I need to get that common base if I'm going to solve this one. So pretty much I need to get 49 in terms of 1/7, or I need to get 1/7 in terms of 49. I need the same base. So I'll go ahead and put, let's see, I'm going to put 49 in terms of 1/7. So instead of writing 49 here, I'm going to put 1/7 to the negative 2. So 1/7 to the negative 2 would be like a 1 with a negative 2 and a 7 with a negative 2 here. So you would end up flipping this around, and you'd end up with 49. Okay, so there's 49 to the 5x plus 2, like that, and then equals 1/7. Now this is a very tough one again, to the 11 minus x. So let me pause there for a second. Remember, guys, you need to have, if you have an x on each side like that, you're going to need to get a common base. That was a very difficult common base to get. Hopefully, I don't think I'm going to give you anything quite that tricky on the test, but you need a common base if you have an x on both sides. All right, so once that's said, though, I can do log base 1/7 and log base 1/7, and that makes it really easy because that cancels with that. I end up with negative 2 times 5x plus 2 equals, that cancels with that, 11 minus x. So let's go ahead and keep solving this. So distribute all this, so I get negative 10x minus 4 equals 11 minus x. So I'm going to go ahead and add x, so I get negative 9x, and I'm going to add 4 equals 15. X equals 15 over negative 9, or negative 5 over 3. X equals negative 5 over 3. So negative 2, negative 1.6. All right. Going to keep going with this. Number 13. 7 to the 5x equals 12. Okay, so I only have one x. I need to get that out of the exponent area, but that's a lot easier. So I just need to cancel out this base. So I'm going to do log base 7 here, log base 7 here, log base 7 of 7 cancels. So I have 5x equals log base 7 of 12, like that. So that's going to give me some decimal. Let's see. Log base 7 of 12. That gets me a decimal of 1.27699. 2769. I think that was the decimal. Then all I have to do to solve for x is divide that decimal by 5 to get rid of this times 5. So if I just took that, divided by 5, that's my answer, 0.255398. That would be my answer. Okay, let's keep going with this. I like this one. Actually, I'm going to just write directly below it. So it says 3e to the 4x plus 9 equals 15. So I've got to get to the point where I can get rid of that base. Yes, I only have one x there. So I can solve for it. It's pretty easy, but I got to get to it first. Get to where I have just a base by itself. So I'm going to subtract 9 from both sides. 6. And then divide by 3, so e to the 4x equals 2. Now I have a base e right here, so I can get rid of that base e by doing a natural log. So remember, natural log is the same thing as log base e. Okay, so I'm going to do log base e of both sides. That's what I'm doing, essentially. Let me get myself some more space here. So I'm going to do log base e. I'm going to do log base e of both sides. And log base e of e cancels. So I have 4x equals log base e, or natural log of 2. And then I'm going to divide by 4. X equals natural log of 2 divided by 4. And that would be my final answer. So x is, let's go ahead and find out what that is. Log base e of 2 is that divided by 4 is 0.173287. Approximately 0.173. I'll just round it to 3 decimal places, like that. All right, so that's number 15. Let's keep going with these. At the end of this video, if you keep watching, I'm going to show you the easiest way to solve all of these, by the way. But it's a trick. It makes sense, but it could be useful in a time where you're like, I don't know what to do. So keep watching the video. Watch the very end. I'll show you how to do it, hopefully, if I remember. So I'm going to keep going through these. Number 21, solving that. Here, let me go ahead and actually do this again. Okay. Okay, now this is the same concept right here, guys, except now we're given logs first and we're asked to solve. So if I'm given the natural log of 4x minus 7 equals the natural log of x plus 11, well, if these are equal, then e to that power is equal to e to this power, because the powers are the same. So this is e to a power equals e to the same power, which is a true statement. But here's the benefit of that. E to the ln, remember, that's log base e. So e to the log base e cancel. E to the log base e cancel. E to the log base e cancel, so I have 4x minus 7 equals x plus 11. And I can go ahead and finish solving this from here. So I'd subtract x from both sides, I'd add 7, I get x equals 6. Like that. Okay, let me go ahead and do another one. Number 23. So if I have log base 2 of 3x minus 4, I'm doing this one, and I have equals log base 2 of 5, then that means I can do, without writing it again, so I'm going to just start speeding up a little bit, I can do 2 to the log base 2 of that, and 2 to the log base 2 of that. But 2 to the log base 2 cancels. So I end up only with 3x minus 4 equals 5. I'm going to add the 4, so I get 3x equals 9, x equals 3, like that. All right, let's do another one. 25. So this says log, ooh, this is a good one. I like this. This is going to teach you to think a little bit different. Log base 2 of 4x plus 8 equals 5. And guys, just so you know, the way I'm getting answers right here, I am not this quick at math. I went through these problems before I actually worked them up here, so I could explain them, so I didn't have to hesitate when working these things out. Anyway, if I'm going to get rid of log base 2, so I can get to that x, I'm going to go ahead and do 2 to the log base 2 of 4x plus 8. But if I raise this side to 2, then I also have to raise this side. Or I have to do 2 raised to that side as well. So these cancel. Log base 2 of 2, or 2 to the log base 2, I'm sorry. And I'm left with 4x plus 8 equals 2 to the 5th. There's no canceling here. So what is 2 to the 5th? Well, you could type it into the calculator, or you can just know that it's 32, and then I can solve it from there. 4x equals 24. X equals 6. That's a kind of a cool way of thinking. I can raise this side to 2 to that power, and then have these cancel. And then what I do to this side, I have to do to this side. So I take 2 and I raise it to that power. But those don't cancel. So I just write down the whatever number it was. So 2 to the 5th happened to be 32. All right. Here's another example of that. Number 27. Log base 7 of 4x plus 9 equals 2. So I want to get rid of this log base 7. So I'm going to do 7 to this power. But if I do that to this side, I have to do 7 to that power as well. So these cancel. I get 4x plus 9 equals 7 squared, which is 49. Subtract 9, so I get 4x equals 40 and x equals 10. Like that. Okay, let's see here. Right here, I've got log. Now, it doesn't give me a base. It just says log, and that's all it says. But that's okay, because we know log without a base by default is log base 10 of 12x plus 9. Oh, minus 9, sorry. 12x minus 9 equals log base 10 of 3x. Now, if I want to get rid of base 10, then I'm just going to do 10 to the power of that equals, and what I do to one side, oh, unfortunately, I'm not going to be able to write it there or make a gap. What I do to one side, I have to do the other. So 10 to this power equals 10 to that power. 10 of log base 10 cancels. 10 of log base 10 cancels. So I end up with that. Subtract 3x, add the 9, so I get 9x equals 9, x equals 1. And we can check all these answers by plugging them back in. Last one. Oh, a quadratic. Look at that. I like it. So this one right here. So I have log base 2. If I want to get rid of log base 2, then I raise this side 2 to that power. This side, I have to do the same 2 to that power. So log base 2 of 2 cancels. So I have x squared minus x minus 6 equals 2 to the second power is just 4. I'm going to go ahead and subtract 4 from each side. So x squared minus x minus 10 equals 0. And the reason I set it equal to 0 is because, remember, a quadratic, you have to solve using the quadratic formula. You could solve it maybe factoring. But here's the deal. With 10, the only factors I can think of is 1 times 10 and 2 times 5. So factoring is not going to actually solve this one. You might be able to, on 32, when you guys are working through it, you might be able to solve that using factoring. I'm going to go ahead and use the quadratic formula. So negative b, that's 1, plus or minus the square root of b squared, that's 1, minus 4 times 1 times negative 10. All of that over 2 times a, which is 2 times 1, 2. Okay, and that's what my solutions for x is going to be. So 1 plus or minus 1 plus 40, so square root of 41 over 2. X equals that. I don't know what the square root of 41 is. So let me go ahead and just type that whole thing in. Why not? Actually, let's do 1. Let's just see what the square root of 41 is real quick. So I'm going to do 1 plus this and 1 minus that divided by 2. So 1 plus that divided by 2 equals 3.70. 3.70. And if I did 1 minus that divided by 2, so 1 minus 6.403124, I don't know, we'll just play it safe, divided by 2, that's negative 2.70. Negative 2.70-ish. Okay, so those are my two answers. Let me show you something now. I told you at the end of this video I'm going to show you the easiest way of solving these things. And it really is the brainless way of solving them. You don't have to even think. Now, if I did all that right, then I should get the same answers when doing this. If I did not do it right, then I don't know where I messed up in there, but the concept still remains. You can solve all of these this same way. Now, here's the way you do it. Realizing that log base 2 of x squared minus x minus 6 equals 2, we can type both of these into the calculator. And just to end this video, I'm showing you guys how to do this in case you ever get stuck. So one of them was log base 2 of, I wish I could remember, x squared, let's go ahead and see, x squared minus x minus 6. X squared minus x minus 6, like that. Okay, so there's one graph. The other graph is going to be, so look, I type this in, and one y equals, and then the other one, like here's the graph of the other one, it's just 2, simply 2. Now, here's what we're doing. Where this equals that, that's the intersection. Where the blue graph that we just did, the log base 2 of x squared minus x minus 6, where that graph equals 2 is right here. Oh, sorry, not there. Right here and right here. So if I wanted to find out exactly where those were, I would just do menu, analyze graph, the intersection, and I'd say here to here. And look, it's at negative 2.7. That's the answer we got a second ago. And the other one should be at positive 3.7. So let's go ahead and do it. Menu, analyze graph, intersection, positive 3.7. That's the easiest way to do any of this stuff. So let me do it one more time and just prove that it works. That's another way of checking your answers too. So if I wanted to do something like, if you're intimidated maybe by number 22. So number 22 could be as simple as solving it by doing natural log of 2x minus 4. So I'm going to go ahead and do the natural log of 2x minus 4. And it's saying that that is going to equal the natural log of, I can't remember what's on the right side. Let's go back here. Which one was I doing? 2x minus 4, and then natural log of x plus 6. Again, this is just the easiest way. If you don't understand this for some reason, this is the way I would recommend at least passing the test. You should come into tutoring to understand what you're doing, though. Natural log of x plus 6. Natural log of x plus 6. Okay? The intersection of these two lines, notice it's happening over here. That is the solution. I think on this one, it might have been 10. I'm not sure what it was, but here it is. I'll tell you what it was. Analyze graph, intersection. Yeah, it was 10. Okay, that's the easiest way to solve these. X equals 10. That's where they intersect. Okay, so with that being said, that'll be the end of this video.